All right, so today is November the 3rd. We're looking at one-to-one function. Now, one-to-one functions are injective. This says a function that maps elements from X, function f that maps elements from X to Y is called a one-to-one function if and only if every element of Y is mapped onto one and only one element of X. I actually don't like how that is said. I actually prefer if it was said this way, that every element of Y is the image of one and only one element of X. I prefer if it was said this way. So a function f is one-to-one or injective if and only if every element of Y is the image of one and only one element of X. This means that no two elements of X can have the same image in Y. Now, a one-to-one function is called an injective function. Now, we can prove that functions are one-to-one in either of the following ways. We can show that f of x is is a one-to-one function if f of a is equal to f of b, then a must be equal to b. So if you make f of a equals to f of b and a is equal to b, then the function is one-to-one. The second approach is to draw the sketch of y is equal to f of x and draw a line parallel to the x-axis. F of x is one-to-one if this line cuts the graph at most once. And that last phrase is important. It's one-to-one if the line that you draw cuts the graph at most once. And when you're explaining it to the examiner, you must also use the exact same language. The horizontal line, in order for your graph to be a one-to-one function, every horizontal line that can be drawn through the graph must cut the graph at most once. All right, so let us see what I've just said in action by looking at example 9. Example 9 says, show that f of x is equal to 2x plus 1 is one-to-one, is one-to-one, or is an injective function. So example 9, again, show that f of x is equal to 2x plus 1 is a one-to-one function. Now, this is approach 1. Approach 1 says f of a, we need to make f of a be equal to f of b and then see what happens. Now, f of a is actually 2a plus 1, and this is equal to 2b plus 1. Now, 2a plus 1 minus 1 is equal to 2b. 1 minus 1 is 0. Therefore, 2a is equal to 2b. Then, if I divide both sides by 2, I'm going to get A is equal to B. So if you have a function such that if f of A is equal to f of B and the A is equal, if you can show that if f of A is equal to f of B, then A is equal to B, then the function is one-to-one or injective. So I can probably make a statement since when or if, when, let me say when, since when f of A is equal to f of B, A is equal to B, f of x is 1 to 1. Or in other words, f of x is injective. So let's do the alternative approach. So the alternative approach is to sketch a graph of f of x is equal to 2x plus 1. From our knowledge of CSEC and maybe ADMAF, we should be able to sketch this graph easily. So this is my y-axis and then my x-axis. So everybody should remember that f of x is equal to 2x plus 1 is a linear function, and that the graph of a linear function is a straight line. You should also remember that if f of x is equal to 2x plus 1, 2 is the gradient and 1 is the y-intercept. Now, 2 being the gradient being equal to 2 and being positive means that the graph of f of x is equal to 2x plus 1 slopes upwards. From left to right, the graph of f of x is equal to 2x plus 1 slopes upwards. That's 1. And 2, the graph of f of x is equal to 2x plus 1 cuts the y-axis at y is equal to 1. So my graph could look something like this. Now, of course, this graph goes on forever in both directions. It cuts the y-intercept is 1. And this is a graph of f of x is equal, a sketch of the graph of f of x is equal to 2x plus 1. Now, what the theory says is that for f of x, for the function f of x to be what? 1-to-1, every horizontal line that can be drawn through the graph, let me use the specific language, every line drawn parallel to the x-axis must cut this graph, every line that can be drawn parallel to the x-axis must cut this graph at most once. If it cuts it at most once, the function is 1-to-1. If it cuts it more than once, or if it doesn't cut it at all, the function is not 1-to-1. So I can draw a horizontal line, a line parallel to the x-axis. When you do this, you should use a ruler. Now, I'll notice that this line cuts the graph at most once. So at most, there is one intersection. So I can make a little statement to explain my understanding. Every horizontal, every line drawn parallel to f of x to the, sorry, to a graph, sorry, to the x-axis through the graph of f of x is equal to 2x plus 1 will cut the graph at most once. Therefore, f of x is equal to 2x plus 1 is injective, which is just another way of saying 1 to 1.